All right, so we're talking about probability. And we're having a little quiz. The quiz is tomorrow. It's in the 85% category. So that means that this is the first thing that's going to really majorly affect your grade. And there's one of the things topics that's on there is theoretical versus experimental probability. All right, right now I want you to shut your iPads. I just need your full attention for a minute. You won't need to take any notes on this next part. You just need to understand it. iPad shut. All right. Turn them, when I say that, turn them upside down. That way you're not reading something else by accident. Or not. All right, when I drop my keys, what's the probability that these two black things are going to touch each other? The fob that you open and shut the doors with and the key itself. What's the probability they'll be touching? I don't know. You can't even probably do a theoretical probability, but what could you do? Experimental. So I drop my keys 10 times, and oh, they're touching. 2 out of 10 so far. Dropped them again, not touching. Dropped them again, not touching. So I'm up to 3 out of 4 times it was not touching. Oh, now they're touching. So that was 2 out of 5 times they were touching. So experimental probability can help me figure out probabilities when I don't know the theoretical one. Theoretical is good for things like a die that's very predictable. Okay, it's got 6 things and there's a 1 in 6 chance that it will be a 1, etc. But if I actually rolled it 1,000,000 times and it never came up 1, would you be suspicious that it was a weighted die? Yeah, I'd say so. In fact, you do it a whole bunch of times, your experiment should come out to verify your theoretical probability or something's wrong. Remember, this is the law of large numbers. You have to do it a whole bunch of times. You can't just flip a coin 3 times and say, oh, came up 3 heads, something wrong with the coin. No, you have to do it a really big number of times. All right, next topic, sample space. That's all the things, all of the things together that happen. When you roll 2 dice, a lot of people don't understand that there's 36 things that can happen. They say, no, no, no. There's only, you can get a 3, a 4, 5, 6, 7, 8, 9, 10, 11, or 12. That is 10 things. 10 things can happen when you roll a die. It's not really true. It's actually 36 things that can happen. And they're listed here, for example. You could get a 1 and a 1, or a 1 and a 2, or a 2 and a 1. And you might say, but that still gives you a 3. Yes, but they're different. They're different things because they're different dice. Here's another way to think of it. Do you get that there's 6 things on the first die and there's 6 things on the second die? So when I multiply it together, I should get 36 things that are possible? That's called the counting principle. So actually, there might be a different name for that one. Anyway, either way, when you multiply your choices together, you get your total number of things that could happen. And there are 36 things for rolling a die. So right now you need your iPad back open again, or paper, and I want you to figure out what's the probability of rolling a 3. I want you to know there's out of 36. I want you to list what the possible things are that you could get that would give you a 3. Things you want. Make a little list of them. And I'll tell you what's possible is 36. So what's the probability of rolling a 3? Once you've got it, zoom in on it, turn your iPad towards me so I can see what you think the answer is. Keep it turned. Keep it turned. Not saying you're wrong. You actually might be right there. Just trying to make sure I get answers from everybody. You do not have to reduce it, but you can. Still waiting for a lot of you. Come on now, this isn't a super hard question. How many different ways can you make a 3? All right. So what are the things? I saw a lot of people said 2 out of 36. I said some people say 3 out of 36. How many ways can you get a 3? Well, you could get a 2 and a 1, or you could get a 1 and a 2. How about a 3 and a 0? There's no such thing. You can't get a 0 on one of the dice, can you? All right, so yeah, there's only 2 ways. So it's 2 out of 36 was the right answer. All right, here's a harder question. What's the probability of rolling a 7? Figure out all the different ways you could do it. Remember that it's out of 36. Okay, so it is, how many different ways to make a 7? There's a 1 and a 6. a 6 and a 1. You wouldn't believe how many people think there's a 7 and a 0. Can't roll a 7. How about, I mean, on one die. You could roll a 2 and a 5 and a 5 and a 2. Or a 3 and a 4 and a 4 and a 3. That adds up to 2, 4, 6 things. 6 out of 36 also reduces to 1 out of 6. Raise your hand if you knew that one. Okay, good. Moving on. Independent versus dependent. These dice are independent of each other because if I roll the one, the second one has no idea what happened on the first one. Okay, now you might, oh, I just rolled a double 6. You might feel like, because this one got a 6, that there's less chance because of laws of the universe that this one become up a 6. And that's not true. It's equal chance that it's going to come up a 6. It feels like, well, I couldn't roll 2 6s in a row, so somehow the laws of the universe are going to come down and make this thing not come up a 6. But actually, they're completely independent, and they don't know what happened right before. So if I roll 3 3s in a row, and I go to roll another 3, it's not like the odds of a 3 have gone way down. Now it can't happen, another 3. No, same exact probability. Okay, so they're independent of each other. But when is it dependent? When it's dependent is if, for instance, I have these 3 dice, a red, a white, and a blue. And if I were to say, take one of them out, and you don't know which one I just took out. Now I say, what's your probability of getting the red die? You need to know what I took out? So it depends on what I took out of the set of 3. If I took the blue one out, now you know there's a 50-50 chance of getting the red one. But if I don't tell you what I took out, you can't tell. So what you're saying is it depends on what you got the first time. So if it depends on what you got the first time, then it's an independent situation. So the example here about the marbles is where if you take it out and you keep the marble out, then it depends on what you got the first time. It's dependent. Hold on just. All right, so here we go. This one is about reading these charts. These are called, I can't even think of the name. Somebody must remember the name. What it's called? What? It's probability related to a chart of some sort. No, that's different. I remembered it. It starts with a C. It's not actually called a chart. It's called a table. It's called a something table. Yes? Contingency table. There you go. Okay, you will not be tested on what it's called, but you'll have to know how to do them. So this very first one is super simple. Probability of picking a female achieving only a high school diploma. Now, this is not, it didn't say given anywhere. It's just what's the probability you'll get a female achieving only a high school diploma. So would this be a female that is getting a high school diploma? Right? All right, so it's 232 out of how many different people could I pick from? Well, it didn't say given. It didn't say given it's going to be a girl. So it was 3172. So 232 out of 3172. Hold on a sec. All right, so probability at least some college / male. Don't worry, you're not going to be tested on that, but that means given. What it's trying to say is given you're only going to pick from the males, then what's the probability that they'll at least have some college education? Again, think of it like you're picking a random person out of this group, except it's not random anymore. Who are you picking from? On this problem, who are you picking from? Just the men, the males. So I'm going to only pick from these. So this don't matter, and you better not use those numbers. Okay, use a calculator, divide them, see what you get, and I'll tell you the answer in about 15 seconds here. Yes, a graphing or a regular calculator even would be just fine on this. It would be kind of handy to have one. If you want to use your iPad calculator, it's just fine, but you're going to do a lot of decimals. The test is pretty much all in decimals. I'll pause while you work on it. Okay, just to clarify, it says at least some college education. So it's not just some college. Okay, some college is part of it, but didn't these people with a bachelor's degree have some college? At least some college? Yes, they did. And so did these people. And so, as you might have assumed, it's out of 1570. Yes, that is true. It's out of 1570 because that's what is possible. And the ones we wanted were the 374, the 463, and the 382. You add them all up, and you get, what is it, 1,200 and something, or 1,500? What does it add up to, these three? 1219? Thank you. Out of 1570, and that should give you 0.776. Raise your hand if you had that one right. That's the vast majority of you. Nice job. Okay. Probability a woman slash, which means given, achieving only a high school graduate, meaning that they are only, meaning you can't have somebody who's got some college or blah, blah, blah. It's not a great question because you could be a high school graduate who has also had some college. But since it says only a high school graduate, then we have to say given. This is the given part right here. And then it'll, on the test, we cleaned that up and we just said given. Given that the person is achieving only a high school graduate, then which are my options? High school graduates. Should these guys be included? No. Are these guys or these guys? No. High school graduate. Can these guys be included? These can be included. Is there any more that can be included if they've only achieved high school graduation? No, can't include anybody else. So then it's just out of that little group. And now it's probability of a woman. So we go back to what we want over what's possible. We want a woman out of this possible group. This possible group, woman, 232 over 537. Any questions on that one? You think I made a mistake? It's possible. I do make mistakes. All right. Then we'll move on. This one, it kind of freaks people out because it says four-sided die. Normally dice have six sides, right? This is a four-sided die. In case you've never seen one, they kind of look like a triangle on the top. And then they have a triangular face on the bottom too then. And so then see how they have three sides around the top edges and then one on the bottom makes four? And the assumption here is that they have the numbers 1, 2, 3, and 4 on them. So let's say 1 on this side, 2 on this side, 3 on the back side, and a 4 on the bottom. All right? Then the first thing you'd want to do is make a list of all the things that could happen. If I have two four-sided dice, could I get a 1 and a 1? Is that possible? Yes. Make a list of everything that's possible. Make a list of all the things that are possible, and then I want you to figure out which one of them do you want. You want the ones that give you a sum of 6 or lower, but you should make a list of all of them first. So 1, 1 is a one combo, 1, 2 is another combo, etc. Make a list of all the things you could get. Biggest one you could get is 4, 4. And then figure out which ones you want over which ones were possible. How many are there that you want out of how many are there that are possible? Your answer is something like, 14 out of 18 or something like that, but that's not the right answer, but something kind of close to that. Okay, I'm going to pause for a minute while you make a list of all the things that could happen. Figure out the ones you want or the ones that are possible. I had a question, could we have two 1-1s listed? No, but you would list 2-1 differently than 1-2. I know that seems weird, but if I list them, you can tell the difference here, but do you get how you can't tell any difference if I say 1-1 and 1-1? There's no difference. And so you do not list 1-1 twice, but you would list 1-2 differently than 2-1. Okay, so if I were keeping track, I'd probably go like this. I could roll 1 and a 3, 1 and a 2, 1 and a 1, 1 and a 4, all those. And then I'd say I can roll a 2 with a 1, a 2 with a 2, and just keep on listening. Okay, I'm going to continue my list. 2 with the 2, 2 with the 3, and 2 with the 4, and then 3 with the 1, 3 with the 2, 3 with the 3, 3 with the 4, and 4 with the 1, 4 with the 2, 4 with the 3, and 4 with the 4. Now, what I have as possibles are all listed here, and there are 16 of them that are possible. How many of you knew that? Raise your hand if you had it out of 16. Good. And then, which are the ones, see, when you make a list, it's really not that bad. Which are the ones that have a sum of 6 or lower? Well, actually, all of these here have a sum of 6 or lower, and there's a couple others. That's lower than 6, and that's equal to 6. And so those two, and so pretty much I could say either, now this is a kind of a theme here, I could add up every single one of these and see how many there are, and that, or I could say the total is 16 and take away 3 of them, right? Makes 13. What I'm trying to say is that in probability this happens a lot, where either I can add up this or this or this or this or this or this or this, a whole bunch of ors, or you could take the whole total and subtract off a couple. Let me give you another example of that. Let's say I had this chart, and it was a big, nasty chart that had all these different things that could happen on it. In fact, there's 2, 4, 6, 8 things that could happen on it. And I wanted at least, let's say this was your, oh, I don't know, what's, so heads and tails. Let's make it simple. Heads and tails. Heads and tails. Heads and tails, etc. And I said, what's the probability I'll get at least one heads? Well, I can add up all of the ones that have at least one heads in them, which would be this one, this one, this one, this one, this one, this one, this one. But that one has tails, tails, tails. So I could add up all those arrows, or I could say all of this total would add up to 1 and then take away the one I don't want. You get what I mean? It's the same kind of a deal. Same as here, where I could add up all of those, add up 13 of them one at a time, or I could say, well, it's 16, take away these 3. I could add up all of these, or say they're all going to add up to 100%, but I have to take off that last one. So 1 minus the last one. All right, moving on. This is a different kind of probability called the area model of probabilities, what I've heard some people call it anyway. And basically, you're just trying to figure out the area of the shape you want, divide it by what was the possible area. The possible area here is this whole rectangle. What you want is this little triangle. I want you to figure out this one real quick. It should be easy. These are pretty easy. Figure out what you want over what's possible. Divide them, get a decimal. I'll show you the answer in just a sec. Okay, what you want is this, which is 8 times 5 is 40, but it's a triangle, so what do? 5 by 2, so it'll be 20 over, what was possible was the whole thing along here, which is 12 times 8. I know some people screw that up. 12 times 8, which is 96. 20 out of 96 comes out to 0.208. Raise your hand if you had that one right. All right, good job. If you didn't, as long as you know what you did wrong, you're fine. All right. I don't want to mess with card problems. I don't think we need to practice those because I told you we're trying to avoid those on tests. There's very few of those, if any, on tests because it's kind of unfair because some kids don't know like how card problems work because they don't ever play cards. So, all right, let's do this one. I'm going to make you the little chart really quick. Actually, no, I want you to make the chart. You make me a chart. Remember, the first one is a 24% chance of snow, and let's say N for not snow. So 24.24, and then you should be able to figure out what that is. And then the second day of snow is 35. So you should know what that is. And you'll be able to make me a set of 4. Go ahead, make me a nice, clean, clear chart. You got to practice making these. They are on the test tomorrow. You'll have to know how to make tree diagrams. Make me a tree for this problem. Okay, well, those numbers should have came pretty easily. They're just kind of the what goes with 24 that adds up to 100. So 24 goes with 76. Anyway, to get the totals for the chart, though, you got to do your multiplying. So to get this first spot, the S and the S, that would be 0.24 times 0.35, and I get 0.084. Can you help me by reading me the other three? Who's got them? Come on, just help me. It makes it go faster. 156 and this next one? And the next one? Thank you. And the last one? Thank you very much. Okay. So now, what's the probability of 2 days of snow? Well, that one's simple. I wouldn't even probably need a chart for that one. It's that one and that one, which makes that one. So it's 0.084. There we go. This one, have you got caught on to the whole given thing with the slash? That slash means given it snows the first day. Okay? Well, given it snows the first day, would you please figure out, okay, what's possible? As soon as they say given, you changed it from what's possible. What possible before was all 100% of the things were possible. So you could add them all up, or you could just say 1 on the bottom. But now that it says given, that it snows on the first day, then do you get these things are not possible anymore? You get that? All right. This one's a little weird. Given it snows on the first day means only those two things are possible. So you go say 0.084 plus 0.156. Those are the two things that are possible. Probability of at least 1 day of snow. Do you get how dumb a question this really is? If it snows on the first day, what's the chance it's going to snow? Well, it already did. 100%. Or you could just say, which of these work? Does this have at least 1 day of snow? Yeah. Does this have at least 1 day of snow? Yeah. And you go 0.084 plus 0.156, and you quickly realize they're identical on top and bottom, and so there's a 100% chance. If you just think about the question, given it snows on the first day, what's the chances it's going to have at least 1 day of snow? It's for sure. All right. Not necessarily a dumb question. It's actually a good question because it makes you think, am I doing something wrong here? All right. And now try the last one. Remember, make it a fraction. Because it says given it snows at most 1 day. At most. That can confuse. It confused me last hour. I screwed up the answer because I got confused. At most 1 day means it cannot snow more than 1 day. And you got to figure out, there's one of them is not allowed. Figure it out. Pause while you work on that one. So, if it snows at most 1 day, what's the one thing we can't have? Snowing 2 days. So snow is out. Wait a minute. It says given it snows at most 1 day. So it can't be this, right? All right. So then I should take this writing off of here so we can see that again better. So these things are possible. In fact, all three of them are possible. So you could add them all up, or do you get, I could do on the bottom, either adding them all up or 1 minus 0.084. Did anybody do it that way? That's smart. Yes? Nope. The given is the second part. Don't worry, on the test it'll say it in words. You won't have to try to read that. Saying given, that's why I circled and said given with the circle around it. Given it snows at most 1 day means those three things are possible. Now, probability. It does not snow the first day. Now I get down to which one of these do I want? I want the ones that are n first. So it's this one and this one that I want. On those two, it did not snow the first day. So those are the ones I want. 0.266 plus 0.494 over that. And that will give you a final answer of 0.830. Raise your hand if you had that one right. That was a hard one. Only got half the class. I get why he would get that wrong. That was confusing. I got it wrong last hour because I crossed off the wrong thing. I thought we couldn't have 0.494, but when I read it over again, I was like, oh, I'm wrong. Some kids caught me. So, all right, so all I'm trying to say is these are hard. They can even make me make a mistake. Doesn't mean that justifies like, oh, nobody can do them. It's just you gotta be careful. Yes, sir. That's correct. Why did I pick them for the top? Is that what you're asking me?
We already know it adds to 0.76, right?
Yes, you could absolutely say 0.76. Now, will they add? If I actually do them, 6, yes, it'll add up to 0.76. Now, I agree. You could look back here and say that one was it.
And on the bottom, it's 0.04.
That's correct. Ah, I think I see where you were going, but then you caught your mistake. Okay. All right, moving on. If there was any thing I would encourage you to be getting good at, it's the given thing. The conditions on your probability, if it says given. And all you really have to do is make sure you change your denominator when it says given. And that'll answer like half your questions. The hard part is figuring out what's possible and putting that on the bottom. Okay, your assignment is, I looked at it, it's a very reasonable sized assignment. It's called Review Worksheet, so go ahead and find it. You've got a bunch of time to work. Please, if you get stuck on stuff, bring it up here and ask. And there is a Schoology quiz you can do for practice if you want to. They're under tests and quizzes on Schoology. So if you want to have more practice, go for it. I'm not going to put this one in the grade book, so it's optional. I wanted to not require it because that'll give you some time to work in class where you can ask me questions. All right? Okay, get to work. If you need help, ask.